All right. Hi, everyone. I'm Craig Kirsteins. Hopefully, you're in the right session. Otherwise, it's too late to leave now because they're closing the doors. So I'm going to talk a little bit about Postgres today. Quick show of hands to start off with. How many people here already use and run Postgres? Those are my people. Thank you. For the rest of you, hopefully, I can convince you a little bit by the end. So first off, Postgres is really well loved. Believe it or not, it's ranked as the most loved database for actually, I think, a couple years in a row now. Stack Overflow just came out with 2020. And DB Engines is a popular database engines ranking that names kind of an official kind of the year of the database, what was the big one that year. And it won 2 years in a row. So we'll drill in a little bit to how it had this resurgence and why it's loved by, in particular, developers. And we'll cover a little bit by enterprises as well. But know that it's kind of won over developers' minds over the past 10 years or so. Quick show of hands. How many people in the room would consider themselves a developer? Wow, a lot. And the rest of you kind of admins or DBAs or decision makers, I would assume. So there has been a big shift in the last 5 to 10 years, I would say, that developers now are making kind of the decisions on the stacks you use, the frameworks, and the databases as well. If you look at 10 years ago, it was the DBAs that controlled the database. They would say, hey, you give me the thing you want to do. I'm going to create the schema. I'm going to create the indexes. I'm going to manage it all. And over the last 10 years, we've had this big shift to application developers choosing the database. And Postgres is one that's really, really well loved by developers. RedMonk is a small industry analyst that talks about this a lot. There's actually a really great free book called Developers Are the New Kingmakers. It's like 100 pages. It's not super long. I encourage you to read because it talks a lot about this shift to developers kind of making more and more influential decisions and driving products. All right, so a little bit of history about Postgres, because I think it's interesting. It's an open source database, but I think it's unique in open source. There's a lot of things that are open source, like you write something, you open source it, but it can still be owned by a company. Open source just means it's out there and people can contribute to it. Postgres has a very unique license and structure in that no one can actually ever own it. It can't go and be bought by a company. There are individual committers that contribute to it from multiple different companies, but no one can ever actually own the database. So it will forever be open source and kind of this community shepherded project. It has the same roots as a lot of other databases. So the name Postgres comes from Ingress, which is one of the earliest databases. So if you look at things like DB2 and Netezza and other things, they have the same database relational roots as Postgres. And then it releases really, really regularly on a yearly cadence. So you don't have to worry when the next version is coming. It's fall, winter time of every year. Sometime between September and November, you're going to get a new release. Those things get committed 6 months to a year in advance. So we already know what next year is going to look like. So while it's an open source project and doesn't quite have a roadmap, you can kind of tell what's coming with it. So really interesting to be able to follow along and know what you're getting in the future. So, but why do people love it? And in particular, why do developers love it, since they're making all these decisions about technology and what goes into place? Here's the really high-level summary. And I'm going to drill into a lot of these in a little more detail. But it's really, really feature-rich. So it's got a lot of data types, really powerful and advanced indexing, full-text search. Django is a popular Python framework, and it has this concept of batteries included. I really, really like this concept, because it says, it has whatever I need to do things. Like, it ships, on Christmas morning, if a toy comes for my kids, and it doesn't have the batteries, and now I've got to run to the store, like, cool, you gave me a toy, but it did nothing for the kids. This idea that everything's in the box that I need is a really powerful one. And with Postgres, yeah, it's a relational database, but as soon as you need unstructured things, it's there. As soon as you need text search, it's there. Geospatial support. So you don't have to go and deploy a new database to get all these features. So let me drill in just a little bit more. So data types. This is something that's really, really simple, and you don't think about as an exciting thing when it comes to a database, but I really, really like the Postgres approach. They're really liberal when it comes to data types. So you've got things like text ones and numeric ones. You've got geometry types for geospatial stuff. One really, really useful data type is arrays. So you're probably using arrays somewhere in your application. Why map this to a join within a database when you could just put an array into a column? So if I've got things like categories or tags, this is great for an array field. And then I can have the same kind of constraints. Range types are really, really, really useful. So it's a from and a to. So in a database, usually when you have a started at, ended at. Now I can actually put that into a single column and have various constraints, like the ended at can't be after the started at. And I can actually enforce this within the database so it's all correct. We can limit the number of people that can attend a talk session occurring at 11:45 so that we don't have too many people signed up in the room. So we can actually do this directly within the database really natively. A big exciting one that people get really excited about is JSONB. So Postgres got support for JSON, it's going on 8 years ago now, but we kind of cheated. So when we said we had JSON support, we accepted JSON, we validated it, and we threw it into a text field. That was with Postgres 9.2. So we said we had JSON support. We were one of the first databases to do it, but we kind of cheated. JSONB is a binary representation of the JSON on disk. So much like a Mongo database, it's compressing it. It can index into it. It's much, much smaller. A great, great option. B stands for binary. I have a colleague that jokes that B stands for better. I like that approach. If you're using JSON in your database or you have unstructured data, it's a great approach. And it works pretty natively. So if you look here, like if I've got a products table and I have the name of the product, but then I want to have all these attributes, right? E-commerce, this is really common. If you think of an e-commerce store like Walmart, and you've got all these products in different tags and categories and sizes, like you just want this kind of key value structured nested JSON document for it that you can display all these properties about the product. And then you can query it on anything, right? So you can query on things like, give me the author, or filter for this category of fiction books. Really, really simply, natively, without having to go build this through a relational model, but also without having to move to a document database. So you've got this flexibility of, hey, I've got my relational structured data, and I've got unstructured data. So I would encourage, when you're doing something in your application and it's a unique data type, take a look at Postgres and see if it has that exact same data type there. It'll allow you a bunch of optimizations, a bunch of constraints. You can ensure that the data is correct. Really, really, really powerful here. So another big one is indexing. Postgres adds an index type about every year. Most databases have 1 or 2 index types. Postgres has this history of a new database kind of showing a new index showing up every year or so. B-tree is the really, really common one that you expect. Gen and Gist, a really short simplification of them. Gen is really useful when you have multiple values in the same column. So if you think of like an array, right, where you've got multiple values in that array, you probably want Gen. If you think about indexing JSON, really, really useful there as well. A quick look, it's really, really simple to actually, I mentioned JSON, right, and we looked at how it works. To add an index and index every key and value within that JSON, all I have to do is create this one index. Now as I query that data, it's going to use this Gen index filter, be really, really efficient. So now I've actually just added a bunch of unstructured documents to my database, added one index, and then I can query this in a really, really fast way, join it against my relational tables. And you've got other ones too. So SPGIS, Brin, really, really useful for really large data sets. And when I say really large, billions, tens of billions, hundreds of billions of rows that naturally cluster together. So if you think of things like phone numbers that often have a prefix and kind of a location, or zip codes, that kind of data naturally clusters together. And SPGIS and Brin can be really, really useful. And so that's all what's in the box already with Postgres. Now, what I also love about Postgres, it's a really solid, stable database. The number one thing I care about in my database is that it's good, it works, and it doesn't lose data. If you have a database that loses data, it's not so hot. So it focuses on being really slow and stable. When it adds a new data type, it makes sure it's a standard spec. I've actually had debates with the core community about an email data type. But there's actually not a spec for what is an email address. You can put all sorts of crazy, weird things in there. And so that's the reason actually Postgres doesn't support an email data type, because you can't validate it in the way you'd expect. But we want these new shiny features. Postgres is really unique in that it has this low-level extension framework. So these are really, really low-level hooks. This isn't just like an add-on on top. This is deep within the core of the database that you can come in and change how Postgres works. So you can add things like HStore was before JSONB. It's a key value store directly in your database. PostGIS is a really, really rich, advanced geospatial database. It is well regarded as the most advanced geospatial open source geospatial database and turns Postgres into like a complete geospatial tool. If you want partitioning in your database, you've got pgpartman. And so all these tools hooked deeply into Postgres and changed the behavior. We'll talk a little bit more about this, but Aura2PG is a really interesting one to help with migrating from Oracle to Postgres. So if you've got this legacy Oracle application that you're looking to migrate, you want to see how compatible it is or how much work it is, it can really help quite a bit. And then you've got a big, broad ecosystem. So it's been around for 20 years. People have been developing against it. Timescale is actually a VC-funded company that builds an extension that turns Postgres into a time series database. So if you're doing things that are time series, metrics-based, log analytics, oftentimes IoT, it can be really, really useful to compress this IoT data, scan it down, aggregate it, that sort of thing. Hasura, really interesting if you're using GraphQL and you don't want to have to build something from scratch. It'll give you basically a out-of-the-box API with GraphQL that you can work with. Then as you build and evolve your application and you want to drop down, you can drop directly down to the database. And then just earlier this year at Build, we announced support for Postgres for Azure Data Studio. Most people with Postgres are used to working in a CLI. I'm personally a CLI guy. It's got a really, really powerful, good CLI. But I know there's this big desire and kind of need for I want some graphical tools to work with. And so we've added support for Azure Data Studio so you can work with both your SQL databases and your Postgres databases all in the same way, in the same place, and collaborate on them. So if you really think about it, right, you've got Postgres at the core. We've got a bunch of extensions. We've got JSONB, which is really, really powerful data type that stands all on its own, really rich indexing, all these features built in that I don't have to go to another database when I need this feature. I can just say, hey, can Postgres work for me? I don't have to go deploy something new. And then when you come to Azure, right, you've got built-in AHA on top of it, the ease of scaling up and out. You've got all these extensions that are actually already supported for you, so you don't have to go build them and install them for your database. It's simply click a button, and you've got this extension now enabled to do something that you couldn't before within your database. And a big part of I think the trend of application developers doing more and more with the database is also like you're not going to go and get a Ph.D. in databases. Like you're not going to go learn about the roots of database theory necessarily. If you want to, let's hang out and chat and grab a beer after. Like I think it's super fascinating, but not everyone's going to do it. So what we've done actually is take a lot of the common insights that you need to do as a DBA, things like what queries are slow and how do I optimize them, and bubble those up directly for you within the portal. So you've got things like intelligent performance that'll recommend indexes automatically. A big pain I hear for Postgres, so Postgres under the covers is just a giant append-only log. When you write data, it writes a new record. When you update a record, it actually marks the old one as dirtied and then writes a new one. Postgres under the cover has something called vacuum that comes up and cleans up all the mess. Now, out of the box, it should work pretty well. But really, depending on your application, you could have to tune this, tweak this. And I hear it's a pain for a lot of developers that, like, hey, I've got a bunch of bloat. I've got a bunch of old data that's there consuming waste. How do I clean this up? We actually just announced a private or public preview of the ability to auto-tune your Postgres database so that you don't have to come in here and tune this and do this maintenance. We'll automatically do it for you and tune it over time. And then, of course, you want it to be safe and secure. So the ability to detect threats early. So we can detect alert you on anomalies. I'll make it easy for you to investigate. Is there unauthorized access? Is there something you should look at? Is there something not configured correctly? That sort of thing, so that you don't have to be an expert DBA to get these kind of insights. So that's a little bit on, I think, why Postgres from the application developer's perspective. Like, when I leave this as the TLDR, like, if you're not sure about something in here, search for it. You'll find a lot of resources. This is very much the 30,000-foot kind of flyby view. But it'll give you, what do you need to know? What do you need to look at? Hey, I don't know what that thing is. Search for it. To cover a few more of these, foreign data wrappers are super interesting. They allow you to connect from within Postgres to another data source. So you can connect from things like in Postgres to Redis, from in Postgres to Mongo. There's the ability to query Twitter from within Postgres. I don't know why you would actually want it, but that's a different story. The fact that you can is always a fun opportunity, right? And as you think about these things, like, okay, what new ones could I use and could exist there? So if you're curious of this crazy idea, if you want to do it, you can probably dig in, and it's maybe already done for you. So shifting a little bit, why do enterprises like Postgres? I hear more and more of a push that it's a well-respected database. It's used. Yeah, we're going to go ahead and deploy some of it. But I think there's a lot of strategic decisions. And as I talk with analysts all the time, too, like Postgres is the one that's kind of winning a lot of these new enterprise workloads, net new applications, greenfield applications. A lot of what we talked about there on the application and history side, right? It's a really solid database. It's flexible. I don't have to always go and deploy something new. But I think there's a few more reasons that are worth drilling into a little bit. So the first, right, it is the same roots as all other relational databases. Like the name itself, Postgres is postingress. So any of these other databases that you probably had deployed had those same roots. It's not like this fancy new reinvented kind of thing. A transactional database is safe. You trust it. There's a lot of eventually consistent databases out there. I don't want my bank typically running on one, right? I want the data to be there, to be safe and secure, and to not lose it. And this is one that not everyone likes SQL. How many people here like writing SQL? Oh, that's actually way more than I expected. How many people like reading someone else's SQL? I saw one hand. We can talk after. I think, yeah. But SQL's everywhere. Like, it is the lingua franca of data. It's how you access it. So as soon as you have a new NoSQL system, what are you going to do? You're going to go layer a SQL API on it to perform your analytics. Like, SQL works. It is the most powerful way to access and work with your data. Postgres has very rich ANSI SQL support. It follows the standard pretty well. It works. Businesses like this. You don't have to learn a net new thing to go of how do I analyze this data. From most organizations I talk to, you already have a relational database. This isn't something new. A DBA knows how to administer Oracle or SQL Server. You probably know how to administer a Postgres database. It's not something completely net new. Yes, it's not the exact same, but it's much, much closer than significant changes there. This is important. As you bring on new tools and systems, there's an overhead to ramping up to learning these. Really important that you can bring in a new system and just operate it. This is a big kind of win here. Every framework you're probably already working with already works with Postgres. You don't have to go and write raw SQL. If you're using Ruby on Rails, if you're using .NET, if you're using Python, all these tools and frameworks already work well with Postgres. It's a thing that's heavily tested against, heavily used. So again, it's just your usual tool stacks and toolbox. And this is a big one. It's much easier to hire for Postgres. Developers want to work with Postgres. Like, it's a stodgy old database that's been around a long time, but somehow it became a cool database. I don't know if you can say that about databases. Can they be cool? But people want to work with it. And I don't know about you all. Hiring is not easy. We're in a great industry. It's wonderful to be in demand, but to go and hire and recruit someone is a month-long process. I'd much rather give them the tools they want to work with. It's much, much easier to recruit for. And Postgres is one of those ones that checks the box. If you looked at it, how loved it is by developers, they want to work with it. They'd rather work with it than other tools often. And the really big one, right, for businesses out of here is reduced total cost of ownership. To kick out an Oracle database and bring in Postgres to get the same experience, it's much cheaper, works the same way. You don't have to learn something net new, but you can actually reduce your total cost of ownership. And so I actually want to invite a couple of people on stage. So I want to invite Roel and Sham on stage to talk a little bit about what Chevron did with OpenText and migrating from their Oracle setup over to Postgres. Thank you, guys.
So I'll move a little bit to the middle. Yeah, thanks for being here, or inviting me here. So my name is Roel Gillissen. I'm a program manager for the Microsoft solution from OpenText. So for you who don't know OpenText, we are the largest... Was that me? We are the largest independent ECM provider in the world. If you look at the Gartner Content Service Quadrant, we're right next to Microsoft up there. And we focus on connecting unstructured content to business applications, right? So think about Dynamics CRM, SAP, Salesforce, that's what we focus on. So, because our systems are always right next to the business systems, they're really important for an organization, right? So, you have test environments, you have acceptance environments, and you have failover backup. So that means that, just like your business applications, it needs to be fully scaled. In our case, that means that sometimes you have 4 or 5 different environments running, besides your production environment. And if we then, talk about the value, right? If all of those applications use expensive database licenses, then, your total cost of ownership goes sky high, right? And, as a vendor, the only thing we focus on with organizations is the return on investment of your investment, right? On the OpenText investment. So that means that, if you have a really high TCO, then the return on investment will be, longer, right? And for us as a vendor, that's bad. But also for the customer, right? And the less money you can spend on new investments or new technologies means less profit for the organization. So as OpenText, right? So I personally take care of the go-to-market for Microsoft solutions with for OpenText, but I also manage the Microsoft partnership. And as part of that, we also need to think about how we embrace these technologies. And although we are cloud agnostic, right? For OpenText, it doesn't matter where you run your software. Our 25 plus history partnership with Microsoft show that adoption of those technologies is really key and easy to do from our experience. So we supported Postgres a while ago for a lot of our solutions, including Documentum, but also the other mainstream application from OpenText, to lower the cost of ownership, but also being able to run copies in VMware. The applications are numerous. So as such, we also now are supporting Azure Postgres in production environments, which we couldn't do in the past because of performance, maturity, things like that. But right now, we're happy to be able to support that also in the production environments. So, that is the value for us as OpenText. And like I said, most of our solutions run on Azure. We also try to adopt all of the technologies like blob storage, Azure SQL, and all of those technologies. And this is, one key solution of that. So Shyam is going to tell a little bit about the experience of using that.
Thank you, Craig. Thank you, Raul. So I'm Shyam Pichimathu. I am the manager within Chevron who supports the content management product suite. Not all of content management, but content management mainly focused to support our facilities engineering. So all the mission critical data. Documentum is a mission critical application for us. And what I wanted to do is I asked Craig how much time I have. He told I have like 10 minutes or so. So this is not going to be a Bollywood story. This is going to be a Hollywood story. I'll get straight to the point. A year before where we were, we had OpenText Documentum up and running for almost 15 years or so. Every time we do an upgrade, every time we re-platform, every time we need to put an Oracle patch, it takes humongous effort from our team, where we were pretty much running an IT shop within Chevron. So what we did was a year before we partnered with OpenText and Microsoft, we had a week-long hackathon where we thought what we can do best. And again, to Craig's point, why developers love Postgres, right? So we asked OpenText, what tools do you guys use to support your thing? What do your developers use? And they told we use Tomcat, we use Linux, we use Postgres. And if the developers are using that, why can't we take that to production and just use that, right? So if it's tested by developers, it should be pretty easy for us to do.
So a year ago, you did a hackathon and you dropped it in, you were in production in a week, right?
Yep. So what we did was we took our platform, which consisted of like almost 160 servers, VMs, with several instances of Oracle database and everything. And we started moving into Azure Kubernetes. And using Azure Kubernetes, we re-platformed the entire Documentum suite, working with OpenText and Microsoft. And we implemented Helm charts on it. And then also, we partnered with Microsoft to get everything in Postgres as a PaaS service. And right now, we are live as of last 2 months. And we are in the progress of migrating the on-prem applications from Oracle to Postgres.
And we were talking a little earlier that like you didn't just say, okay, let me just drop in this. Like you kind of modernized everything.
Yep.
Like before, it was very much that analogy of like, you had your server and you named it and you knew what it was and it was this special VM that you didn't touch. And as you modernized, you kind of went all in with Kubernetes and containers. Postgres is a big part of that.
And thanks for bringing that up, right? So I love to, I'm very proud to say this. Before, if we were even to, or even if you are trying to bring up a development environment from ground up, it will take my team at least 2 or 3 people, probably 2 weeks to get the whole stack up and running. But the way we modernized over the last year, it's 1 hour from 2 weeks. It's not the number I'm cooking it up. It's really 1 hour, end-to-end with Azure DevOps, clicking the Helm install, and the whole stack of Documentum up and running with Postgres behind the scenes.
And so I'm curious a little bit, right? So you said you've got some of them in production. I think we were talking that, I apologize, I think the slide's out of date. Like it was 13 deployments when I created the slides, and I think you said you were up to 15 now.
Yep.
You have them in production, like how is that journey, right? Because like moving a database is not, like I talk to people and every time it's not a relaxing thing. I've helped people move a bunch, but it's a little nerve-wracking every single time because it's a sensitive thing, right?
Yep.
You lose data or there's performance issues or how do you know it's going to work? What was that journey like?
It was a scary journey. It was very scary, but I think we did several hackathons with Microsoft and OpenText. And once OpenText started looking at how this migration process works and they were comfortable with it and Microsoft was comfortable with it, we validated all the data and everything. Then it is like a clockwork. It just started working.
How was the data validation process? Can you talk a little bit? Like how did you move things over? How did you test things?
Pretty much with the, we are doing evaluation with the DMS solution where actually it takes from
Oracle directly
into Postgres. And it looks at all the tables and all the data and what failed and whatnot. So we have the complete history of what's happening.
Got it, okay. And then how are things looking now? Like you mentioned that time to deploy. What's the overall stack look like now? I'm kind of curious if you went from an on-premise kind of database where you were watching, carrying after, probably getting paged for all sorts of things, patching frequently. Like what is the experience like now on the ones that are in production?
So there are still some on-prem implementations in Chevron, which uses Oracle. And last night I was in a firefighting call, troubleshooting and adding indexes and so on and so forth.
So it wasn't your Postgres databases?
It wasn't my Postgres.
Okay.
But with Postgres, I mean, with being in the Azure platform and everything, I have everything in my cell phone. I can watch what my CPU is with any nodes and everything. With Azure Log Analytics, all my logs are being pumped. Who is accessing my database to the nth degree, I will be able to tell from my phone.
That sounds much more peace of mind. So I think the idea to not have to manage your database it sounds kind of refreshing.
Yeah, I don't, the database gods, that's what they call them.
Unfortunately, I have to do that. So that's a horrible business. Don't do it.
Yep.
Cool. Anything else that from that journey that you think is worthwhile to share?
I think the key was our management support where Chevron has always been supportive of innovation, so go figure it out. And if there is value, as long as we are not increasing the cost, which is the major driver, we are actually reducing a lot of cost here by moving to Postgres. And with the management buy-in, where they are saying, go innovate, go figure it out, we just started very simple, how we can take our Stone Age, not Documentum, but Stone Age infrastructure into the great modernized infrastructure where I can control everything. That was the key value. And one more point I wanted to stress is Chevron is an oil and gas company, right? So we are not here to do IT. We will leave the IT to the hands of the experts. Where we want to focus on is set the foundation right, where we don't need to worry about patching, we don't need to worry about upgrades, we don't need to worry about do I need this patch or that patch or whatnot, but where we want to worry about is once I have my data, I know it's reliable, I know it's scalable, can I take the data and add business value? How can I do data analytics on it? How can I show more metrics around it, right? So that was the key driver.
It sounds like an exciting win and a really good synergy on the what developers wanted as well as what management wanted, right? So thank you, great to hear. And then I think if you're curious to hear more, you're giving a talk a little bit later in the theater around 4:20, yes?
Yes. So what we did was we again partnered with OpenText and Microsoft, and what we are doing is we are doing an evaluation, or actually finished an evaluation with the DMS, where we are taking an Oracle database and have migrated successfully into the Postgres, and would love to share that experience in that 4 o'clock
awesome
session.
So yeah, if you're curious, I would encourage you to stop by for a little bit more. Yep. Thank you, guys.
Thank you.
All right, so a few more things, I think to summarize it a little bit. So on the Postgres side, right, a big one for businesses is lower TCO. I think Sean mentioned it several times, right? It's reducing costs. A business cares about that, they love that. Because it's open source, no one can ever own it. You won't get locked in, there is no expensive licensing. It is SQL. Postgres is one of the closest databases to Oracle compatibility out there. So if you got some Oracle and you want to get rid of it, Postgres is probably the closest thing to drop in there. And it's not a new shiny data store, right? You hear that he's managing it from his phone now. It's not a new thing to go figure out how to manage. It's easy, drop in, very similar to what you're already doing. So all of these build on each other. So you've got a really, really rich, feature-rich database. You already know how to work with it. It's a SQL relational database, and then you have the ability to reduce cost. But I was going to do one more thing, but I think it's about 5 more minutes. So my impression of Steve Jobs, my best attempt there. Hyperscale Citus. So one of the big knocks against relational databases is that they don't scale. You scale up, you scale up, you scale up until you can't scale any further. And then you get this expensive appliance that you put on premise, or you migrate to a distributed NoSQL store. Hyperscale Citus, we announced public preview back at Build. We GA'd it, I think you heard in some of the keynotes earlier this week. It's pure Postgres. It's not a fork. We haven't gone and taken Postgres and changed it and manipulated. We've taken and used all those low-level extension hooks and transformed it into a sharded, horizontally distributed database under the covers. So as a developer, it still looks like a single node database. It doesn't look like anything complicated or different. It still looks like a single node database. And you can now just scale it with dragging a slider. So you drag a slider, it adds nodes, data rebalances, it automatically routes queries under the covers. So to give you a little bit of a look at how it would kind of work, if you're doing something like a update on some SQL, you're going to talk to a single coordinator node. It's a standard Postgres database that you connect to. The coordinator is going to know that this data lives down on node 123. It's going to rewrite on the fly, route that query down, update that single record, send that back to the coordinator, and just say, OK, cool, this is committed. So everything's fully transactional. You don't have to know that all of those other nodes are there. And you're looking at single millisecond latency. So it's still like a standard database. We're not fanning things out. We're not kind of waiting for some consistency to get there. It's committed. It's there. Same thing for inserts, for selects. If you run a basic select and you want to just get, hey, I want purchases for this given user that only lives on one node, it's going to push that down really quickly, give you that really sub-second kind of response. Now, you also have the ability to do more advanced analytics on it. So what happens if you want to say, hey, I want to do a count star? Well, a count star is now split up across all of these 3 nodes. My data is spread out. How does that work? So as soon as you actually query that, the coordinator is going to recognize. In this case, we're actually going to do an average, so something more complicated than a count star. We're going to get a sum and a count from every single node, bring that back to the coordinator, and then give you the result. So the coordinators basically get to sum up everything, of the sums, of the counts, and do that final math there. Now, the query we executed was just a standard SQL query. It wasn't anything complicated. It's a basic average query. Under the covers, it's going to actually turn this into distributed SQL that it can execute. Now, it's going to run this across every core in the system. So you can actually see performance benefits of 100x over a single node database because we're parallelizing this workload. So similar to some MPP systems, but we're doing this in a transactional way. So really interesting in that you can start on a really small single server Postgres, and as you need to scale, we can scale to hundreds of terabytes, double digits nodes, extremely kind of large scale databases. We have customers in production with up to a petabyte of data, all as a transactional database. So now on Azure, right? You've got a feature-rich database in Postgres. If you have any feedback on a Azure on Postgres experience, I would encourage you to come up, happy to chat afterwards, swing by our booth. It's a database you can trust because it's reliable, not going to lose your data. It has a long history of being reliable, developed in a good, slow, steady fashion. It can reduce costs if you've got a expensive proprietary database already in-house. And now you don't have to worry about scaling. And then you can actually also run this anywhere. So you can run this on Azure, but Hyperscale is one of the options for Azure Arc. So if you want to take and run it on your own cluster so you have parity with your on-premise stuff that you're still running for whatever reason and need to scale along with your stuff on Azure, you can manage it all in the exact same way. So you can still look up on your phone and manage this for your on-premise stuff now with Arc. A quick thanks, and then a couple other kind of call-outs and notes. So one, if you like Postgres, if you like reading about it, learning about it, I encourage you to sign up for our newsletter. It's once a month. It's generally kind of highly curated content and interesting reading. It's interesting blog posts, things that we see about Postgres that are exciting, that sort of thing. So if you're curious and want to stay in touch with Postgres, I encourage you to sign up and subscribe. Please send us feedback. Let us know what you found interesting in the session. Let us know what you would like to see more of. Hopefully we see you here next year, and we have more sessions about Postgres and can dive deep into all of the internals and that sort of thing. So let us know what you want to hear. And I think we probably have about 5 minutes or so for questions. So thank you, and if there's any questions, happy to take them. Yep.
It works. What are the chances of getting a serverless offering similar to the Azure SQL offering that's out?
Serverless is definitely something we're looking at. Because of the nature of Postgres, it probably takes a lot of changes to the engine that we're exploring. The unfortunate answer is it's not an immediate, quick thing on our roadmap. So definitely something that we're looking at, and the feedback is helpful that you would like it. Any other questions? All right, thank you very much.